In this, we're going to discuss problem solving using recursive methods. Problem decomposition, or functional decomposition, is the idea that we're going to use recursion to solve a similar but smaller problem. A quick analogy is this. Let's assume our problem is to eat a sandwich, and it takes about 8 bites to do it. We have a whole sandwich, and we have the problem, eat sandwich. Well, our mouths simply aren't big enough to shove the whole thing in and eat it. But what we can do is take a piece of the problem, that is a bite, and solve that by chewing it and swallowing it. We still have a sandwich, only it's smaller. We again take a bite, chew, and swallow. We still have a sandwich, only it's smaller. We keep doing that until there's exactly 1 bite left. That is still technically a sandwich. So our solution is take the bite, which is the whole sandwich, chew it, swallow it, problem solved. Sandwich has been eaten. We did it each time by taking a piece of the problem and then recursively calling the solution on a smaller piece of the overall problem. A palindrome is a good example of a recursive type solution. We have a string of characters. Actually, we may have no characters. We could have 0 or 1 or 2 or more. But if we think about it as 3 pieces, the leftmost character, the rightmost character, and then everything in between, we find we have 3 possible cases here. A single letter, 2 letters, or more than 2 letters, and I say a letter surrounded by 2 letters, X, Y, X, where Y can be a single letter or a sequence of many letters. Actually, if we consider Y can be no letters whatsoever, we really only have 2 cases. And that's the way we need to learn to think. It's mathematical, but it makes programming so much more simple. A palindrome checking function needs to address 2 base cases and 1 recursive case. The 2 base cases are if the length of the string is 0 or the length of the string is 1. In either case, we consider it a palindrome. If the length of the string is greater than 1, what we do is we check the 2 outermost characters, the leftmost and the rightmost. Now, it is possible that that could be exactly 2 characters. Fine, we test those 2. Assuming the 2 outer characters are equivalent, we may have a palindrome. We need to recursively check, but let's not check the outer 2 characters. Let's take the substring and eliminate the outer 2 and just check what's left. That is how it's possible to do a recursive check with a 0 length string. If there are exactly 2 characters left to check, we eliminate the 2, we have a string of 0 length, we check it. Well, that's a palindrome. If at any time the outer 2 characters do not match, we cannot possibly have a palindrome, and there's no need to continue checking. To write the method for this, we again start with our signature. Boolean, true or false value, is palindrome, and then the string and the method body. We don't have anything in the method body yet, but we have the form of it. Now we add our base cases. We say if that string P for phrase is less than 2, return true. That is the case of a 0 length string or a 1 length string. Both are considered palindromes. Otherwise, our recursive case is if the leftmost character, or char at 0, is equal to the rightmost character, which is the length of the string minus 1. Remember, the length is always 1 more than the rightmost index because we start at 0. We test those. If they are a match, we then return the recursive is palindrome check, but we take the substring starting at character 1 and going up to and not including the final rightmost character. So the substring shrinks in size by 2. Because the length shrinks by 2 each time we call it, we are driving towards the base case of length being less than 2. The else statement says if the characters do not match, return false. No need to continue checking.